I thought in terms of the format, I don't know what you want to do. Squares are a very interesting property. They're pretty unique. They've been known since the times of Greek mathematicians. The famous Pythagoras theorem is something all of you are aware of. X squared plus y squared equals z squared. Two sides of a triangle, right angle triangle. Squares of those sides equals to the square of the hypotenuse. Very easy to prove geometrically. And there are so many Pythagorean triplets out there. The series is infinite. But then when you get to cubes and fourth powers, such a relationship does not exist. And that's the famous Fermat's last theorem, which did not get proved for 4 centuries, which was only a conjecture until somebody proved it in the late 90s. So a lot of interesting things with numbers. So I thought today we'll probably look at perfect squares and imperfect squares. Perfect squares are numbers where it has a perfect square root. So 64 is a perfect square. Square root of 64 is 8, right? So, but 65 is not a perfect square because you have to estimate it, and you have to really, it's about 8.06 or something, whatever. So I thought we will do some operations with perfect square. Maybe you can ask me to calculate the square first, and I think I'll do that. Let's stick to 2-digit numbers. Maybe we can do 1 or 2, 3-digit if you like. And then we can do square roots of perfect squares, and then imperfect squares. So the imperfect squares, of course, are much harder. So
all right, let's start with finding the
square.
So throw him any number.
2-digit preferably, and then
2 digits.
Maybe we will move on to 3-digit.
Go ahead, Eddie. Give him a number, any 2-digit number.
88.
7744. Is that correct?
Yes.
Thank you. Thank you. Thank you.
I know. I have this one.
52.
2704.
Is someone?
43. Yes.
Okay.
43. 1849.
43.
1849.
Yes.
Thank you.
65.
4225.
Yes.
Want to try something 3 digits?
Yes.
Means I've done quite a bit, but I'm not very sharp today, but I'll try.
3 level. This was 3 level.
101.
10201.
Yes.
Thank you.
Anybody else? 3 digits. That's the easy part.
Huh?
3 6
666. Okay.
Devil's number. That's how you use it.
4435 56.
Yes.
You're very good at the calculator.
It's so hard. Had to think about that one.
Maybe one last 3-digit and we'll move on to square roots.
713.
713. 508369.
Yes.
Wow.
Thank you. Thank you very much.
Okay, so now let's move to roots.
Square roots. What you can do is maybe take a 2-digit number, square it, and I'll give you the square root. Maybe we'll do 1 or 2 of those, and then we'll move on to 3-digit numbers.
Can we do cube?
We'll do cube after. Yeah. We can do cubes if you like. We can do cubes. Let's do that. Let's do square roots, and then we can do cubes. Yeah. Maybe you want to take a 2-digit number, square it, and give me the square, and I'll
1156.
34.
Yes.
Maybe one more.
3025.
55. Maybe move on to 3-digit numbers,
3
square
digits.
it, and give it to me.
Do you have these memorized?
Pretty much, not because I wanted to memorize them, but they're somehow stuck in my head. So that's why 2 digits are
Okay.
not all of them.
You ready, Siva?
Yeah.
218089.
218089.
Yeah.
218089. 467.
Gosh. Good. That is correct.
Thank
Would you like one more 3-digit one?
Yeah, it is good.
I have a good one. But I guess it doesn't really matter because you'll figure it out.
It's good.
How do you memorize it? Is it?
I didn't memorize it.
This one.
This one I calculate.
There's
85084.
885
No, 850084.
850084. $922.
Yes, that is correct.
Thank you. Thank you.
Okay, so shall we do imperfect squares?
I think let's do that. That's much harder because obviously you have to estimate. So maybe 3-digit or 4-digit. I'll go from there.
1042. Oh, your 3-digit numbers.
No, it doesn't matter. 1042, right?
I just pulled it out of my head.
It is 32.22.
32.28.
Okay.
Alright, let's do it again. Let's stick to the rules. Three digits.
He said
I
4.
didn't mean to go above.
You said
four.
4.
So I stopped.
No, it's 0.06 I was off. Okay, sorry.
Still pretty impressive.
Thank you.
If you would have done the next number, we would have done it.
Thank you.
I gotta tell the other guy.
You wanna
Yes,
do
one more word to give us a 3-digit number.
344.
344?
Yeah.
344. 18.555.
Yes.
18.5. Yep.
18.555?
It's 18.547.
Yeah.
Okay.
But you only have to do 2 digits.
But
Okay,
yeah,
18.55. Okay.
Okay.
So.
Okay.
Okay, throw out a 3-digit number. That's the easy part.
Or 4 digits.
Or 4 digits. Anyone? Brendan? 4 digits. Any 4
We have
digits.
to think of
Any
one.
4-digit number? He
Yeah.
has control clause. I want to do my phone again.
4,319. Sixty-five point 73.
72.
65.72.
Just rounding up.
No, it's 65.719.
65.7.
So you said
Okay,
65.
that's pretty impressive.
Thank-
Okay, we'll do one more.
Oh my God.
We'll do one more 4-digit number. We'll do one more root. So
1738.
1738. Cube.
the cube.
To the pound
He's
cube.
going
Oh,
to cube it.
67, the cube of 67 will be 300763.
Perfect.
Okay.
Okay, another 2-digit, and then we'll another cube. Any 2 digits.
87.
87. 658503.
Yes.
I had it in memory. So.
That one doesn't count.
It was in his hand. It was in his hand.
What we can do now is in reverse.
Do the cube root.
Cube root.
Okay.
Well, I have to tell you that actually for 2-digit cubes, the cube root is pretty straightforward if you know, because it comes itself from properties of mathematics. If you know cubes from 1 to 10, then extrapolating it to 2 digits is very straightforward. So because if you know the last digit, then you can get the cube root like that. If it's a perfect cube. So I'm going to just do cube root of your 2-digit cubes just once because it's actually pretty elementary because it comes from principles of mathematics. But I'm going to challenge myself and actually do something which is much harder. I'm going to ask you to cube a 3-digit number and give me a 7 to 9-digit cube, and then I'll take the cube root. That's a lot more challenging. But let's do the 2-digit cubes then because it's sort of simple, but I'll just get the.
So she's gonna get your number.
99.
99. No, cube root. You have to check. You have to.
So
anyway.
Oh, you want a perfect cube.
Yeah.
Perfect triple cube.
Anyway, 99 cube was 970.
Double digit cube. Double digit cube. Start it.
As I
For 2 digits, right?
Yeah. As I said, cubes of
79507.
79507 is got to be 43.
Yes.
43. I'll just move on because I think cubes of 2-digit numbers are, as I said, they lend themselves to easy calculation because of the sheer property. I'm going to challenge myself and say cubes of 3-digit numbers.
Okay.
So take a 3-digit number, cube it, give it to me.
714-73375.
7.
Forgot the number.
7 733. $415.
That is correct.
Thank you. And maybe one more 3-digit cube root, and then we'll move to imperfect cube roots, and that's much more challenging.
$310-288-733.
310-288-733. 677.
Yes.
Okay.
Okay then.
Okay.
Do you want to do the cube root now?
Cube root
Of how
of
many?
imperfect number. So pick anything from
4 digits?
0 digit to 1 digit to 6 digits.
6 digits?
6 digits. Maybe do 4 digits first, and then maybe do 5 and 6.
Oh, I said, darn it.
1028.
Cube root, right?
Cube root. 2 decimal places.
It's
Oh, jeez.
Two decimal places.
Here.
It is 10.07.
09.
10.09.
Okay. Yeah.
All right. 5325.
5325. 17.43.
46.
17.46.
The 4 decimal digit is hard. Actually, 46 is what it is.
You want 6 digits?
Yeah, 6 digits, sure. Alright.
All right.
937461.
937.
461.
Okay. 97.87.
Perfect. Very nice, Siva. Let's end on that note. Thank you.
You want to take it one part further and do a quick root?
A fifth root?
Fruit of a.
How do I find the fifth root?
Let's
Yeah,
let's
no,
just
the
cut to the
computer.
chase and do an imperfect fifth row and see if I can get that.
All right,
You
here we
give
go.
me any number, 1 digit to 10 digit. Maybe 5 digit for or whatever, and then a 10 digit, whatever you
Okay.
want.
So we're like the billions.
How many digits you said?
1 digit to 10 digit. The reason I said
So-
1 digit, 10 digit is the
So what
fifth
about-
root will be a 2 digit number with
1
something.
trillion. That's 10 digits, right?
Trillion is, I mean, well, trillion is 12 digits, but.
Okay,
wait.
so
Wait, what am I missing here? Wait, hold on.
8 824
That's a case number.
824943.
Pretty sure God signed that piece.
And we're trying to figure out the fifth root.
15.30.
2-5.
15.25? Okay. 0.05. Okay. Maybe one more,
Nope, not for me.
five digits perhaps, and then maybe a 10 digit, and we'll call it.
Can't even do it right.
32768.
Oh, that is 8. 8 to the power of minus 3 to 6.
Obviously.
That
Four three five 9804.
4359804. 21.29.
2-8.
Okay.
Very close.
Yes, 21.276.
Yeah.
That is.
All right, well, thank you, Siva.
Thank you. Thank you for organizing.
And I brought some goodies.
Thank you so much.